Okay, let's get it going. This is a Gauss grade 8 2026. I'm gonna start from problem number 16. Well, interestingly, I think this paper is actually easier than this year's grade 7 paper, except the last problem. But anyways, we're gonna start with from 16. So in this diagram, there's a, 45 right angle triangle which is has a hypotenuse of a square root 8. So this is a divided by square root. This is 2 and this is 2. And what is the smallest number of these triangles needed to completely cover a square with side length 8? If you have side length 8, the area of the square is 64, right? This is a 64. And you basically have a, for this is 2 times 2, but divided by 2. That is a 2. So each one, for each of these triangles, the area is 2 and the total area is 64. So at least, okay, let's be rigorous. That is to say total area is 64 and you've got like pieces of 2. So you at least need 32 pieces. But is 32 actually enough, right? Fortunately, the shape here is very neat. You just need to use 2 to get a little square, and then you can pave the whole thing using this kind of little square thing. So this is doable. I mean, I know this is obvious, but to be rigorous, you need to show this. Before, 32 was just a minimum value, and now it is achievable. So it is 32D for this problem. Okay, yeah, I didn't even use the whiteboard, but I guess I would need it for this one. Okay, so this is the thing, and can they be the same? Oh no. Okay, so different digits from the list 0. Okay, there's a, okay, and what is the value of u? Okay, I need to copy the whole thing over. This is the problem, and let's see if this is the, okay, I just to take trouble to do that, write that again. T-U and 1. These are numbers. You've got these to choose from. If you consider this one thing, you can have 3, 8, and 2, 9. But if you consider this 7 thing, I guess it is better because, it is either with a carry or without a carry. If without a carry, it should be 2 and 9. That's the only like possibility. If there's a carryover from a previous digit, then it is actually, this one, I mean, the difference between them should be 8. But it is not possible to have 0 and 8 because how can you have a 0 as a leading digit, right? So it is not. So it is just a 2 and 9. So it is determined 2 here and 9 here. So these are already gone. And if this is a 2 and 9, then this is A3, or in whatever order, it doesn't matter. It's the first digit. Yeah. Any digit. In any digit, it doesn't matter. The order. So now moving to the 10th place, the middle digit here. This is we have 2. This is a carryover. So it's 5 plus something is something. What is that? 5 plus 0 is 5. No, yeah, that's it. 5 plus 0 is 5. So what is u? U is 5. Is 5. Is there a 5? 5D. Okay, yeah, good. So this is it. This one is, I believe, repeated from Gauss 7. So I'm gonna skip this one. It's contained in a Gauss 7 video. Okay, now let's look at this one. This one is pretty close to Gauss 721, I guess that thing. But anyways, so this is a parallelogram and this is a triangle. So AB is 8, CD is 12. What is the ratio of this guy to this guy? Okay, so this is a 12 divided by 2. This is a 6. This is 8. Basically, this is 8. So it's 8 to 6 or 43. This is a E. Well, this is a super easy thing. But okay, the next one. Okay, this is getting interesting, but yeah, let me just okay, I don't need to copy the thing. You just need to find A, B, C. Okay, so A plus, yeah, this is a 90 over 11. Good. Clear all. A plus 1 over B plus 1 over C is 90 over 11. So you first do something with that number. this number 90 over 11 is just 8 and what is the mixed number 2? 11 and 2. So a is 8, right? A is 8 and this thing is 2 over 11, so 1 over this guy is 2 over 11, essentially meaning b plus 1 over c is 11 over 2 as a mixed number. That's 5 and 1 over 2. Yeah, so b is 5 and c is 2. If you I'm sorry, this is 5, it should have been 5 and c is 2. So 8, 5, 2, you add them up, you get 15. Do about 15. Yeah, this is a 15. Cool. Yeah, that's 20. And then we are on to part C. So far, so okay. So how many positive ways can you arrange these? Assign a different number from this list. Okay, so basically you arrange 3 and 4 so that the value of this guy is odd. So it's a, A times B plus C thing. How many ways? In total, there are 6 ways, but let's look at this thing. Oh, no. Yeah. So you've got 3, 4, 5, right? 3, 4, 5, yeah. 3, 4, 5. You want to end up with an even number, odd number, I'm sorry. You want to end up with an odd number. So in terms of parity, it is basically 1, 0, 1, right? 1, 0, 1. If you do this thing, it is 1. If you do this thing, it is also 1. So anyways, you end up with an odd number. So nothing to worry about. It's just like permutation 3. That is 6. Any one will do because of this. I mean, you don't have to take 3, 4, 5 into consideration. Just use 1, 0, 1. I mean, modular arithmetic. But anyways, even if you test out all 6 of them, you will notice that it's always an odd number at the end of it. So that's it. 6 of them. E. Okay, the next one. In a diagram, A, B, C are on a circle with a center D and a radius 5. So okay, why don't we just copy the thing over? Yeah, I think this is okay. Yeah, and can we just it's just like a second nature. Every time you have a circle and when a radius is mentioned, why don't you just connect the radius? Connect. I guess this is not important. I mean, these two are not necessary here, but why don't we just do that? Okay, AB is 4, so this is 2. BC is 6, so this is 3. Radius is 5, and yeah, this is this is a perpendicular bisector because this is the center. So DA and DB are the same because they're the radii, 2 of them, and then this is on the angle bisector, right? Sorry, this is on the perpendicular bisector. And since M is the midpoint, so DM would be perpendicular to AB. It is very intuitive, but I want to be rigorous. That is why I'm glossing over the thing. And same with this thing, right? Perpendicular bisector, midpoint, you connect them, you get a perpendicular line. This is right angle. And then you apply the Pythagorean theorem. This is 4. This is 21. Yeah. And what's the question? The question is, what is the area of the guy in the middle? Oh, this is the area would be half 2 times 21 plus 3 times 4. Well, let's try not to use a calculator. I don't know, maybe you are expected to use one here, but so it's 6 plus something and this guy, right? What is that? I believe 2.5 to the power of 2 is 22 point, sorry, it's 2025 because let's just use whole numbers. I feel better with them. So this is like 2025. So this is a little below. How about 36? 46 squared. 46 squared is basically 41 plus 1 squared. That is 2025 plus 91. That is that over? Yeah, that is over. That is over. That is over. I mean, this is more than 21. So this number is between 4.5 and, I mean, this guy is between 4.5 and 4.6, 4.5 something, 4.5 something, and plus 6. So this guy is actually 10.5 something. So if you take this as a multiple choice question, B is the only possible thing, right? Because it's either 10.5 or 10.6. Unfortunately, there's no 10.5, so I think B is the only like possible choice here. And that's for this geometry problem. Yeah, and then we probably do one more, and maybe we can do everything and leave the last one till the final video. So yeah, let's go make our way all the way to 24. Okay, cool. 23. Well, this is the thing. Why don't I just copy the whole thing over? Good. There's a die. A die. Dice is the plural? No, a die. I don't know. Okay, anyway, a die is created with integers with 6 faces. The first time the die is rolled, the numbers on faces change in the following way. If the number rolled is odd, all numbers on the die doubled. If the all even numbers remain the same. If the number rolled is even, then even numbers are halved and all numbers remain the same. It's rolled a second time. So what's the proper? Okay. Let's try not to be clever. Just let's write out the complete story. So you start with these things, right? It is either odd or even. If you end up with odd, what happens? All numbers are doubled, so even numbers remains the same. So two even, double, and even. And then you get odd, even. You get like odd numbers doesn't change. Even numbers 1 on 2 7 4, right? This is how the game pans out. And if it's rolled, what's probably that the second number rolled is 2. So you want the second number be 2. You want this number be 2. The rolled the second time. No, what the second number rolled is 2. Okay. No, not this second number. The second number rolled is 2. That is to say the second number rolled is 2. So if you are here, the second number rolled is 2. It is like just a 3 out of 6. If you are here, then it is just a 2 out of 1 out of 6. 1 out of 6. And what is the probability of getting odd number in the first place? That is okay. This is a 2 out of is that 2? Yeah, 2 out of 6. Even number is 4 out of 6. Yeah. So 2 out of 6, 4 out of 6, and then you add them. This is a 5 9. This is a 6 9. 10 over 36, simplified as 5 over 18. So it should be D. This is a basically like expectation thing, but you don't have to know this word. It's just like, because it's just like 2 rounds. So after the first round, everything is pretty clear. Everything is in front of you, and yeah, I for a second I misunderstood the thing. I thought like the number in the second. No, it's like the second number rolled is 2. So yeah, and then you have the probability. So it's probability times probability, and then multiplicative principle, and then additive principle. Yeah, that's it. Cool. This is 23. Then we've got 24, and then we're gonna pause. 24. Okay. This is it. Seraphine and Jamie are playing catch with special rules. They start by standing 1,500 centimeters apart. Okay, one throws the ball to the other. If the ball is caught, both players each take 6 centimeters step away from each other, both of them. If it is not caught, the person who missed the catch takes 20 steps towards the other player. The person who missed the so when they stop playing catch, they're like this apart, 1,720 centimeters apart. Of the following, which number of throws is not possible? Oh, this is basically a Diophantine equation or Diophantine equation problem. It is not. I, I thought it was a game problem. No, it is totally irrelevant. It is just saying you start from this number, and every time you either plus 120 or minus 20, right? One of them, yeah, minus 20 towards each other, yeah. And after a few operations, you end up with this number. So let's say this one happened x times, this one happened y times. You are basically saying 120x plus 20y is what's it, like 220, right? The difference between them. This is the like the delta. This is the increment. What is that? Which number of throws is not possible? I mean, total number of throws is x plus y. So which is not possible? I mean, for x and y. Okay, that's it. Let me first simplify the thing. So let's do 26x minus y is just 11, right? This is it. So where's x plus y? 6x plus y minus 7y is 11. That is to say 6x plus y is 7y plus 11. So how about mod 7? This is a 6x plus y what is that? Is a 4 mod 7. So x plus y is actually 3. I mean, this is not obvious. You can try. Yeah, it's actually the inverse. It's some advanced number theory stuff. I mean, for an 8th grader, probably it's a bit advanced, but it doesn't matter. I mean, you can try if let's say x plus y is 1, it doesn't work. 6 and 4 are not like congruent. They're not equivalent in terms of mod 7. If you try 2, it's 12, that's 5. 3 is 18, it's just okay. 18 minus 14, right? You try 4, that is 3, not okay. You try 5, that is 2, not okay. Yeah, so basically that is it. Yeah, but it's like you just take inverse. I mean, this is a concept in number theory. Anyways, x plus y should be 3 mod 7. Otherwise, it is not possible. I mean, this is like necessary. Okay, it's not sufficient. It is necessary. In fact, y have to be positive and blah 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 blah. But this is probably enough. So this is like at least not rejected. This is not rejected. So this is a kind of rejected. Okay, this is a 42, not rejected. This is 7, not rejected. So this one is definitely rejected. So this is not possible. I mean, I'm gonna stop here because this is a multiple choice question. I'm not clear whether the other things are possible. This is definitely not possible. Probably one of them are not possible either because they can make a negative y. Probably that is not the case here because even if you take the smallest one, you inject it here, you notice that this is a 60. So this is probably 7 and x is 3. You can solve it anyways. So you're pretty safe. But this would be, I mean, something extra to do on this problem. Right now, the point is that B is definitely not okay because it doesn't even satisfy the, this thing, and this is a necessity, right? So I mean, this is just a B. If you want to be lazy, you don't have to do anything else. But even if you want to be certain, you can try out the rest. Every one of them would be solvable in terms of the Diophantine equation. And so the answer is B. Okay, that is 24, and that's all for this video. I'm gonna talk about problem 25, the last one, in the next video. See you later.